to Free Coding Academy's How Do Computers Work series, episode 2. This video covers how CPUs work. First up, what is a central processing unit or CPU? A CPU is a microprocessor. So a microprocessor is a chip that performs calculations and controls how data moves around in a computer. CPUs don't store data long-term or display anything directly. Instead, CPUs process the instructions and control the activities of the other computer parts. So how do CPUs process instructions? CPUs perform all tasks by following a cycle known as the fetch, decode, execute cycle. First, fetch. The CPU retrieves an instruction from memory or RAM. Next, decode. The instruction is interpreted by the control unit to determine what action is needed. Third, execute. The CPU carries out the instructions, such as performing calculation, transferring data, etc., etc. So this cycle happens millions or billions of times every second, depending on the CPU's speed. Next up, what are the internal parts of a CPU? So first up, you have the arithmetic logic unit, and this performs mathematical operations and logical comparisons. Next, you have the control unit, and this directs the flow of data and manages the instruction cycle. Next, you have registers, and these are small and fast storage locations for immediate data and instructions. Next, you have cache, which is high-speed memory built into the CPU to store data that is used often. Next, you have a clock, and this helps operations run at the same time by sending regular pulses measured in gigahertz. Next, how do CPUs handle multiple tasks at the same time? So modern CPUs allow users to perform several tasks at once in the following ways. CPUs have cores, and each core can run its own instruction stream. So for example, if you have a quad-core CPU, that can handle 4 tasks simultaneously. Next, they have threads. So cores are further divided into threads that allow CPUs to efficiently switch between tasks. Next, they use something called pipelining, and this is when CPUs run several instruction cycles at the same time. So for example, the CPU may begin fetching the next set of instructions while it is still decoding the previous set. CPUs can also guess future instructions and execute them early to be more efficient. Next up, instruction sets and machine code. So CPUs operate using machine code. Machine code refers to binary instructions specific to how the CPU was built. And machine code is defined by an instruction set. So each instruction is a binary pattern that tells the CPU what to do. So compilers translate high-level code like Python or Java into machine code the CPU can understand. So how do CPUs interact with the rest of the computer? The CPU communicates with other components via the motherboard's buses. So first you have data bus, which carries actual data. Next you have the address bus, which specifies where data should go or come from. And then you have the control bus, which sends commands and timing signals. And that's it. Thank you so much for watching. Please like, comment, and subscribe, and watch episode 3 on how the motherboard works next.